Nope, we're not talking about black holes. Alright, this is something bigger, better. Let me ask you guys, we are currently on the search for interplanetary travel, right? So what are we going to do? Build larger, faster rockets? Nope, that's where black holes come in. Okay, you may think we humans can go from one place in space to another through black holes, but what about getting out? Well, the answer to that is white holes. Most of you probably know what a black hole is. If you don't worry, we've got you covered. When stars burst in a supernova, black holes arise. Black holes are areas of the universe where matter and energy are so densely packed that their escape velocity exceeds the speed of light. But what exactly is a white hole in the universe? White holes are hypothetical cosmic areas that operate in the exact opposite manner as black holes. Nothing escapes from a black hole, and nothing can enter a white hole. Easy. Okay, you'll have to be a bit more creative for a second to get this. It is National Imagination Day, so let's talk about some beautiful creatures. Unicorns are comparable to horses, but far rarer. Similar to these creatures, but even bigger, astrophysicists easily make out white holes by examining the surroundings around black holes while believing there is no mass within the event horizon. So what happens when there is a black hole singularity with no mass? White holes are completely hypothetical mathematical concepts. We do know that ignoring the singularity's mass will make life a lot easier if you work in black hole mathematics. It's that easy. They do not exist in reality. It's not as if these scientists detected an unusual amount of radiation and then invented some fictitious white hole ideas to explain it. Let me make this a bit clearer for you. For example, if you start with 5 cupcakes and give them away, you will soon run out. You can't give anything else out right now. In circumstances, you cannot count down past 0. Sure, slips off paper with I owe you 1 cupcake scrolled on them can be delivered, but it would be crazy to say that negative cupcakes exist and can be handed to persons based on the existence of negative integers. Wait, did that sound weird? If it did, imagine a tunnel where everything that was pulled into the black hole would emerge. It would seem appealing to our knowledge that most things are binary. If there's an off switch, there must be an on switch somewhere. And white holes appear to provide a crucial counterpoint to black holes' finality. Where does all the sucked up stuff go? So, what have we got right now? The recent findings contradicts past predictions that these fictitious space-time shortcuts would collapse in an instant. The massive shift is generated by minute alterations in the mathematics of relativity, which is used to describe such wormholes, resulting in a significant shift in our overall picture of how they work. To learn more about these white holes, you must understand how general relativity works. In essence, relativity is similar to a machine. Enter some data, such as a mass or a collection of particles, and the computer will calculate how that collection will behave over time due to gravity. Everything in general relativity is based on movement in space and time. Objects begin in certain physical locations, move about, and finish up in various situations, while the principles of general relativity remains unchangeable. The theory itself provides a considerable deal of freedom in numerically representing those coordinates. Physicists refer to these various descriptions as metrics. Consider the measurements as several ways of explaining how to get to your grandmother's house for Thanksgiving. Getting it? Similarly, physicists may use some metrics to describe the same situation, and one type of measurements may be more useful than another. Comparable to starting with street directions and then switching to a napkin to double-check if you are at the correct landmark. Why don't we drop all of our assumptions and get to plan? It is reasonable to wonder what might happen if someone tried to go through a theoretical wormhole. This is when the mechanism of general relativity comes into play. Given that this is an intriguing situation, let us study how particles behave. Wormholes, in contrast to common assumptions, are hazardous. White holes are unstable and most likely do not exist because the high pressures within the wormhole let it to spread out and break the moment it develops, much like a rubber band. What would happen if you tried to push stuff down it? Best wishes. I'm just joking. A white hole seems just like a black hole to a spacecraft crew looking from afar. It has way, it may spin. The event horizon, which is the bubble boundary separating the item from the rest of the cosmos, might form a ring of dust and gas. But if they kept looking, the crew may see something unthinkable for a black hole. Yes, a belch. A theoretical white hole is just the inverse of a black hole. It is a black hole seen backwards in time. As we said before, once matter approaches a black hole's event horizon, nothing can escape its powerful gravitational attraction. Similarly, a white hole is an area in which space-time flows inexorably outwards and is what thought to have an event horizon, a radius that prevents any stuff, including light, from entering. The white hole is predicted to produce light at the same levels as a black hole. In fact, the mathematical interest in black holes led to the development of the white hole theory. While accelerating, observers see time differently. This does not apply to slower observers, example, those traveling at a constant pace or who are motionless. And the speed of light is independent of all motion. Following that, Einstein presented his general theory of relativity, which established gravity as a distortion of time and space rather than an actual physical force. Carl Schwarzschild used Einstein's field equation to solve the mass equation in empty space-time, a region devoid of all sorts of matter. The popular Schwarzschild metric emerged from this. Although the equation itself is extremely difficult, simply described, it is a mathematical representation of a black hole. Schwarzschild discovered an equation for a completely static black hole with no charge or change. This is an eternal black hole, which means that its size has never altered and it has always existed. As we previously said, all events occur infinitely distant in the future at or beyond the event horizon. And so, these events never occur to an outside observer. The Schwarzschild metric shows that at the idealized black hole, space becomes time and time becomes space, reversing their roles and causing the black hole's singularity to occur at some inescapable future time rather than a location. When we reverse time in a true black hole, we see a fading star. But when we reverse time in an everlasting black hole, we see a white hole. Okay, let's wrap up all the measures and ideas right here. Well, all we have discussed until now is known as the white hole theory. But does theory guarantee reality? The explanation is that we are unlikely to ever discover a white hole. This is due to the fact, even if white holes exist, light beams emitted would have to go over the event horizon, which is made of infinite space-time, and would never reach us. Furthermore, the white hole is the inverse of the Schwarzschild metric-created eternal black hole. There are no eternal black holes, or black holes had a beginning. They are formed by collapsing stars, they contain charge, and they have not existed eternally. A breach of the second law of thermodynamics is required for both the Big Bang and the white hole. That is where we got stuck. And guess what? We're still stuck there. So, to wind up the entire concept of white holes, we know very little about space, which is a vast expanse of stuff. Scientists have long been baffled by the light balls that appear to float above the dome of our sky. However, we've come a long way since the Earth was supposed to be flat and at the center of the universe. We've launched rockets into space, left footprints on the moon's surface, and orbited satellites. We have witnessed the birth and death of stars using some of the most powerful telescopes ever created. However, there are many unsolved questions, gaps to be filled, and answers to be found. One of them is the well-known black hole, and now we have the white hole. Anyways, what exactly do you think about the white hole? Is it real, or is it some fictional theory? Anyways, please share your thoughts in the comment section below, as well as any details we might have missed. You see, what we have here is an extraordinary story about fascinating science. So as the video ends, did you like today's episode? This isn't the end of the tale. More exciting content will be released in the upcoming days, and we, here, will bring you the best of it. That's all for today. Make sure to subscribe to our channel to see more videos like this one. While you're at it, enable post alerts so you don't miss any of our future uploads. If you like the video, give it a thumbs up. I hope you like the video. We'll see you at the next one.